Okay, so now the rest of the lesson will be in your notes. Objective is to use the quadratic formula to solve quadratic equations. Actually, we're going to be solving polynomials, not just quadratic equations. Quadratic equations are polynomials of degree 2. We're going to focus more on degree 3 today. But we're going to start with a review of quadratic formula, which you did do yesterday, but you had the second block didn't really have a lot of time with the teacher, so I'm going to go back over it. So x is equal to negative b plus or minus the square b squared square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients of the squared term and linear term and the constant term. So you have to use the quadratic formula. You can only use the quadratic formula if your equation is in standard form. In other words, if you have a number or letters or any terms on the right hand side, you need to move those to the other side so that you have 0 on the right hand side. So standard form. So I'm just going to do a couple of examples because you did do some for your homework last night. 2x squared minus x equals 4. This 4 has to be subtracted from the right hand side so that I have 2x squared minus x minus 4 equals 0. Remember, there's no like terms over here, so the 4 does not get added to the other terms. You leave it separate. So now I know a is 2, b is negative 1, and c is negative 4. So in my quadratic formula, I have x equals negative 1, so negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4. Okay, make sure you use parentheses under here, and I'm going to show you why in a minute. All over 2 times 2, because a is 2. 2a is 2 times 2. Okay, so under your square root, you need to put this in your calculator. So that thing under your square root goes in your calculator, and I'll show you, if I can find my calculator, how to do that. Okay, so I already have it in here. I'll do it again though. So you've got parentheses, negative 1 squared minus 4 times 2 times negative 4. Okay, when you put that in your calculator with parentheses, you're not going to have any mistakes. If you don't use the parentheses, you're going to end up with mistakes. When you put that in your calculator, you should get 33. So that's what's going to be under the radical. So now I have negative 1, which equals 1, plus or minus. Now this whole thing that I circled here is now reduced to 33 because I just put it in the calculator and figured out what that equals, over 4. If you can simplify this thing under the radical, like we just reviewed, then you have to do that. In this case, you cannot. But I am going to split up my top 2 terms so that I have 2 fractions in my answer. So my final answer is 1 over 4 plus or minus square root of 33 over 4. And then you would reduce these fractions if you can. In this case, you cannot, so this is your final answer. The next example is x squared plus 6x plus 9. I'm going to skip that one, and I want to go to example B down below in the got it. So we're going to do x squared plus 4x minus 3. And I have a equals 1, b equals 4, c equals negative 3. Okay, so when I use the quadratic formula, I'm going to get x equals negative b plus or minus the square root of b squared minus 4 times 1 times negative 3, all over 2 times 1. So negative 4 plus or minus and I do 4 squared minus 4 times 1 times negative 3. So 4 squared minus 4 times 1 times negative 3 minus 4 times 1 times negative 3. So that's in your calculator, and you press enter, and you get 28. So this number is now 28. And then 2 times 1 is 2. So the 28 is not, is going to be, I can simplify that. So 28 is 4 times 7 and 2 times 2. So I have a pair of 2's. So that's going to be 2 on the outside, 7 stays under the radical. So now I have negative 4 plus or minus 2 times the square root of 7 all over 2. Now I want you to split that into two fractions. So I have negative 4 over 2 plus or minus 2 root 7 over 2. Well, I can reduce negative 4 over 2 to just negative 2. And I can reduce the square, anything under the radical, you don't mess with at this point. You've already simplified the radical. What's under the radical is going to stay there forever. But if you've got a number outside the radical that can be reduced with the denominator here, then you have to do that. Well, I know 2 over 2 is equal to 1, so I'm going to put a 1 in front of there. Well, you don't really need the 1, so you can just use square root of 7 instead of putting the 1 there. So your answer is negative 2 plus or minus the square root of 7. Okay, so the key is to use this quadratic formula to find imaginary solutions. Imaginary solutions are going to have I in the answer. So you're going to start out by getting your A, B, and C, making sure your equation is in quadratic or in standard form with a 0 on the right, and it is. So A is 2, B is negative 3, and C is 5. So I'm going to put negative 3, because B is negative 3, plus or minus square root of negative 3 squared minus 4 times 2 times 5 over 2 times 2. So that's your x. Okay, negative 3 is 3, plus or minus, put this in your calculator, negative 3 squared minus 4 times 2 times 5, negative 3 squared minus 4 times 2 times 5 equals negative 31. And then 2 times 2 on the bottom is 4. I almost wrote 2. Is 4. Okay, let's split this up. I've got 3 over 4 plus or minus, well, the square root of negative 31, you're going to have a I, right, because square root of negative 1 is I, and then you have a square root of 31, which can't be reduced. So this is going to be I square root of 31 over 4. The only thing you have left to do is to move that I, because the I always goes last. So 3 over 4 plus or minus square root of 31 over 4 times I. So your answer is that. So you always look under the radical. If it's a negative, you have to do what we did with the I. Pull that I out and move it to the end of your answer. So you've got two examples here I want you to try. Stop the video, try the examples, and come back and I will give you the answers. This one, you have A is 3, B is negative 1, C is 2. So x equals negative 1, which is 1, plus or minus, and negative 1 squared is 1, minus 4 times 2 times 3, minus 20. So I have 1 minus 24 is negative 23. If you put it in your calculator, you should have gotten that. Times 2a, which is 6. So this is going to be 1, 6, plus or minus, and negative 23 is going to be I times the square root of 23, because 23 is not factorable. So it'll be square root of 23 over 6 times I. And B, A is 1, B is -4, C is 5. So x equals -4, which is 4, plus or minus square root of -4 squared. So 16 minus 20, -4 over 2 times 1, which is 2. So square root of -4, let's look at that. Square root of -4. Square root of -4 would be I times the square root of 4. Well, the square root of 4 is 2, so that's going to be 2i. So this is going to be, I'll do a different color, 4 plus or minus 2i over 2. Now we need to split that up and reduce if we can. So I have 4 over 2 plus or minus 2i over 2. 4 over 2 is 2, and 2 divided by 2 is 1, so we just have an I there. Okay, so now we're going to move into the new material for today. So we're going to be solving the different ways that you learn how to solve quadratics. We're going to do the same thing and apply it to polynomials, only we're going to throw in synthetic division with that. First, to solve solutions on the graph, you're just going to graph the x-intercepts. Or to use the solutions to graph an equation, use the solutions to graph the x-intercepts. So a polynomial of degree 3, so we know it's degree 3, it's cubic. It could have at most 3 roots and 2 turning points. It doesn't say whether it's positive or negative, so we don't know where the end behavior goes. So we're just going to wing it here. But we do need to make a coordinate grid. You don't even need to put anything on your y-axis because we don't know the y-intercept. So we're just going to wing it and make a bare bones graph here. We know one of the solutions is at -3, so that means it has an x-intercept at x equals -3. We also have an x-intercept at 1, 2, 3, and 1 at 4. So I'm going to make this a positive cubic function. So I'm going to start down here, cross the x-axis here, cross the x-axis here, and come back up. Yours doesn't have to look exactly like that, but basically a cubic function, remember the end behavior is opposite on both ends. So your end behavior will be pointing up on one end and down on the other. That's really all you need to worry about for that. So to find the roots of the polynomials by graphing, say you don't know the roots, but you want to find them by graphing, you're going to enter the equation in your y equals menu and graph the equation. If it doesn't come up, just hit zoom 6, and you may have to zoom out. So you hit zoom out and enter, but it should show up the first time for a cubic function. So if the solutions are integers, so you look at the graph, you can see they're integers. You can use your trace key on the calculator, or you can go and look at the look for y values equal to 0. Y value is equal to 0, and then take the the x value at, remember the x value when y equals 0 is a solution. So this will be your root or solution. If the solutions are not integers, you have to press second trace. When you're in the graph, on the graph screen, press second trace number 2. Set your left and right bounds, and then guess. When it says guess with a question mark, press enter and tell it to guess. And that'll give you the point where it crosses the x-axis. What are the solutions of this equation? So you can put it in your calculator. Let's clear everything out of here. and go to the y equals menu. Put x cubed in there, x cubed plus 4x squared minus 39x minus 126. And then press your graph. And I'm looking here and I see a solution here, here, and here. And I also have my table up. Well, I can see these are integers. I know one of them is -3. I'm just going to say, okay, that's -3, 4, 5, 6, 7, -3, -7, and if I count up, 1, 2, 3, 4, 5, and the other one is at 6. So I have 3 solutions at -3, 7, 1, 2, 3, 4, 5, and +6. So -3, -7, and +6 are my solutions. And it didn't show, I didn't see the ends of this. So to sketch a graph, you're just going to wing it on this also because you don't know where the y-intercept is. So it's coming up, and I think it went like that. Well, mine's not perfect, I apologize, but this is fine. Okay, so you try this one, and you should get, so stop the video, put it in your calculator, come back on, and it should be -7. Oh, I did the wrong one first, sorry. This is going to be, it looks like I made a mistake. Yeah, so your first one is actually going to be, the one I want you to do yourself is going to be the x cubed plus 3x squared minus 18x minus 40 equals 0. When you put that in your calculator, you should get the solutions of -5, -2, and 4. So -2, -5, 1, 2, 3, 4, and again, just wing it. And your graph should look something like that. Okay, that's how you solve by graphing. Now what if I need to solve a polynomial using synthetic, if it says use synthetic division to solve a polynomial, and instead of graphing, then you're going to just use, usually they'll give you one of the roots, so you can use that in your box for synthetic division. So you have 1. So this says solve the following if one of the roots is 1. So I know one of the roots is 1. I know it's cubic, so there's 2 more roots. So we're going to use synthetic division, and you're going to see why in just a minute. 1. So this is going to be x squared minus 3x minus 10. So the remainder is 0. So I can see if I can factor this. If I can't factor it, then I'd have to use the quadratic formula to get the solutions. Remember, you can solve a quadratic equation by factoring. So let's factor that. Let's see what we get. We get factors of -10 that add up to -3. That's going to be -5 and +2. So I have x minus 5, x plus 2. Then you're going to set those factors equal to 0 and solve that. So you have x minus 5 equals 0 and x plus 2 equals 0. If I solve this, I have to add 5 to both sides, and I get x equals 5. And in this one, you would subtract 2 from both sides, so you get x equals -2. So I have 2 solutions here, and one of the solutions they gave me. So I have a 1, a 5, and a -2 are the values of x in this function. If I cannot factor that, if I could not have factored this thing right here, then I have to use the quadratic formula. And I'm just going to abbreviate that. Use the quadratic formula. So they're giving me the fact that -1 is a root. And you don't have this blank on yours. I meant to take it out and I didn't. So if -1 is a root, then use synthetic division with -1 in the box. So I put -1, 1, -3, 1, and 5. Bring down the 1. I get a remainder of 0. So my equation is x squared minus 4x plus 5. Well, factors of positive 5 that add up to negative 4 isn't going to work, because the only way you could do that is to have one positive and one negative. So we're going to have to use a quadratic formula. So a is 1, b is negative 4, c is 5. So negative 4 plus or minus square root of negative 4 squared minus 4 times 1 times 5 over 2a, which is 2. 2 times 1 is 2. So we get negative 4. I'm going to go down here and do it. Negative 4, which is 4, plus or minus, and under the radical, you should get negative 4, and then 2 on the bottom. So now x equals this thing, reduce. And I know the square root of negative 4 is 2i, because we did that earlier. So 2i over 2. Well, 4 over 2 is 2, and these 2's cancel out, because when I divide that, it equals 1, so I just have an I. So 2 plus or minus I. So use the quadratic formula to find the other solutions. So the first solution was negative 1, and I have 2 plus I and 2 minus I, because that plus or minus means I have a plus and a minus in my answer. I have two answers, one was with a plus and one with a minus. So you're going to solve these two. And for the first one, so you need to stop it. And if I put 3 in the box, the first one you can factor, the second one you have to use quadratic formula. So I know that my roots are just going to be the opposite of these numbers. So they gave me 3, and I have 4 and negative 2. So those are my values of x in this function. The second one, you have to use a quadratic formula. So after you do your synthetic division with 4 in the box, we end up with x squared minus 3x plus 4. So I have a is 1, b is negative 3, c is 4. So x is going to equal negative 3 plus or minus square root of negative 3 squared minus 4 times 1 times 4 all over 2a, which is 2. When you put this in your calculator, you get negative 7. So I have 3 plus or minus square root of negative 7 over 2. So square root of negative 7 would be 7, or I times the square root of 7, because 7 can't be factored. So I have 3 halves plus or minus I root 7 over 2. And I just need to move that I to the back of that. So 3 halves plus or minus square root of 7 over 2 with an I here.